Hey guys, Mr. Backerberg here. In this video, we're going to be looking at trig functions of an angle. So what's going to happen in here is we're going to be looking at angles plotted out in standard position. So remember, that means that the initial side lines up with our positive x-axis, and then we're taking that and rotating it around so that our angle lands somewhere out on our coordinate grid. Now this is going to be our angle theta. And what's going to happen in here is this terminal side is actually going to match up with an ordered pair from somewhere out on our grid. And we're going to use that ordered pair and some information about this picture to help us evaluate some trig functions. So how this is going to work is when we're looking at our angle being plotted out in standard position from this ordered pair, I'm going to drop down this vertical side. And what actually happens in here is we create a right triangle. And trig things are always based on having right triangles. Now, as we're taking a look at our picture and as we're thinking about what happens with x and y ordered pairs, x values tell us how far we're moving left and right. So whatever that x value is going to correspond with this horizontal distance going across the bottom of this triangle. And then y values move us up or down. So this y value in here is going to match up with this vertical height of this triangle. Now what we don't have in our picture in this right triangle is the hypotenuse. And when we're dealing with something like this, we actually call that value r. But what we can do to solve for that r value is some Pythagorean Theorem type of things with these x and y values that we've got in our picture. So if we think about Pythagorean Theorem, it's a squared plus b squared equals c squared. And we know that c is supposed to be the hypotenuse. But in this case, we're dealing with r as the hypotenuse. So we would say something like x squared plus y squared equals r squared. And we're trying to solve to figure out what r is, so I'm going to get r alone. So what I would do is, in order to get rid of that squared on the r, is I would want to square root both sides. So the squared and the square root on the r are going to cancel each other out. So we're going to get r equals. Now we're not allowed to cancel out these squareds on the x's and the y's because of this addition happening underneath that radical. So we have to leave it as the square root of x squared plus y squared. So that's how we're going to calculate our r value using what we know about our x and y ordered pair. Now, next we're going to have to remember some trig things and some information about how we find those. So as far as our trig functions go, our three basic ones are the sine, the cosine, and the tangent. And when we're doing sine, cosine, and tangent, we're always going to refer to a specific angle. And in this case, we're going to use that angle theta. So we're going to be doing the sine of angle theta, the cosine of angle theta, and the tangent of angle theta. Now we've got that SOHCAHTOA acronym that we can use to help us out as far as building these trig ratios. So sine is the SO portion of that, meaning that in order to calculate a sine function, we take the opposite side and divide it by the hypotenuse. So as we're looking at where theta is located in our picture, the opposite side is the y value and the hypotenuse is the r value. As far as the cosine goes, that's the ka portion of the SOHCAHTOA. So in order to evaluate a cosine function, we're going to do the adjacent side over the hypotenuse. And as we look at our right triangle that we have drawn out over here, adjacent to the angle theta is the x, and the hypotenuse is still the r value. And then for the tangent, we've got the TOA portion for the SOHCAHTOA. And the TOA tells us that we're going to do the opposite divided by the adjacent. So in here, the opposite side is y, and the adjacent side is x. Now there are actually a few other trig functions, but they're just reciprocals of these original trig functions. So the cosecant of theta is the reciprocal of the sine. And remember, reciprocal means that we're flipping the fraction over. So this cosecant, if we do the reciprocal of what we know about the sine, would be the hypotenuse over the opposite side. And in our triangle, the hypotenuse is r and the opposite side is y. The reciprocal of the cosine is the secant of theta. So this one we would do the hypotenuse over the adjacent side. So we would take r and divide it by x. And then the reciprocal of the tangent is the cotangent of theta. So here we would do the adjacent side over the opposite side. So we're going to take x divided by y. Now, in all of these fractions, we do need to make sure that the denominator of the fraction isn't 0. If it is, then we'd be getting an undefined value, so we want to try to avoid that. So in this first example, we're going to look at the ordered pair 815. So on my grid, I'm going to sketch out an angle in standard position such that the terminal side corresponds with that 815 ordered pair. Now I'm going to complete this triangle by dropping in that vertical side. Here's my angle theta down in the bottom left-hand corner. The x value is 8, meaning that this horizontal side going across the bottom is 8. The y value is 15, meaning that this vertical side is 15. We don't currently know the hypotenuse of our triangle. That's our r value that we can find by doing the Pythagorean Theorem. So I'm going to do 8 squared plus 15 squared equals that hypotenuse, r squared. Now 8 squared is 64, 15 squared is 225, equals r squared. If we add those values together on the left-hand side, then we're going to get 289 equals r squared. But then if we square root that r squared, because we want to just find r, we end up getting an r value of 17. So this hypotenuse in my triangle is 17. Now from here, I want to start doing all of my trig things. So I'm going to start by doing the sine of theta. So I look at my angle theta. Sine is the opposite side over the hypotenuse. So that's 15 over 17. For the cosine of the angle theta, that's the adjacent side, which is 8 over the hypotenuse of 17. And then for the tangent of angle theta, that's the opposite side over the adjacent. So that's going to be 15 over 8. But then we're also going to calculate our reciprocal trig functions as well. So the reciprocal of the sine is the cosecant of theta. So I'm going to take what I know about that sine fraction and just flip it over. So I get 17 over 15. The reciprocal of the cosine is the secant of theta. So I'm going to get 17 over 8. And the reciprocal of the tangent is the cotangent of theta. So I should get 8 over 15. Now in this example, we're going to look at the ordered pair 3, -4. And on this one, I'm not going to draw out a triangle because it's actually not necessary. The only information we need is our x value, our y value, and that r value. So I'm going to calculate the r, and remember we said we can find this earlier. We said we would do the square root of x squared plus y squared. So in order to find this r value, I'm going to plug in what I know about that x and that y. So this is going to be the square root of 3 squared plus -4 squared. Now when we square that 3, we're going to get 9. When I square -4, I get positive 16. So if I add the 9 and the 16 together underneath that radical, we're going to get the square root of 25. But the square root of 25 is just 5. So my r value is 5. Now I've got everything that I need in order to evaluate those trig functions. So if I wanted to do the sine of angle theta, remember the sine we said earlier was going to be the y value divided by the r value. So the y value is -4 and the r value is 5. As far as the cosine of theta, to calculate that one, we said we were going to take x and divide it by r. So my x value from that ordered pair is 3 and that r value is 5. As far as the tangent of theta, we said we were going to do y divided by x. So that's going to be -4 over 3. And then we've got our reciprocal functions as well. So the cosecant of theta is just the reciprocal of the sine. So I'm going to take that answer that we got for the sine and just flip it over. So it's 5 over -4. The reciprocal of the cosine is the secant of theta. So if I flip over that answer, I get 5 over 3. And the reciprocal of the tangent is the cotangent of theta. So flipping that answer over, we get 3 over -4. So there's the 6 trig values based on this 3, -4 ordered pair. That's going to be it for this video. Thanks for watching.